Welcome to the first tutorial in our LangChain series. Today, we are diving into the powerful world of agents by building a basic ReAct agent using LangChain, LangGraph, and the blazing fast Groq LLM. We'll cover setting up Groq with LangChain, creating custom tools for a calculator and web search, building the agent using the create_react_agent utility from LangGraph, and observing how it executes complex tasks through chain tool calls. First, let's install the necessary packages: LangChain Groq, LangGraph, and utility packages like python.env for managing our API key. Next, we handle environment setup. We import our necessary libraries, load the environment variables, and ensure our groq_API_key is successfully loaded from our .env file. This is crucial for connecting to the Groq cloud.
Now we initialize our Groq LLM. We're using the powerful Llama 370 billion model, specifically the tool use optimized version. Notice the low temperature setting. This is best practice for agents where deterministic, reliable tool calling behavior is more important than creative text generation. The speed of Groq makes this process incredibly fast. The heart of our agent lies in its tools. We define two custom tools, calculator and web_search, using pydantics like calculator input and search input. This is essential for robust tool calling as it helps the LLM understand the required input structure and types. The calculator function safely evaluates mathematical expressions, and the web_search function uses the DDGS library to search the web for current facts. The Groq LLM will use its reasoning ability to decide which tool to call based on the user's query and the tool's description. After running the cell, we confirm that our two tools are successfully created and ready to be used by the agent. With our LLM and tools ready, we construct the agent. We use LangGraph's pre-built create_react_agent utility. The ReAct pattern stands for reasoning and acting. This approach enables the LLM to think, decide on an action, which is calling a tool, observe the result, and then repeat this cycle until it has a final answer. Let's test the agent's calculation skill. We ask, what is 15 times 23 plus 100? As you can see in the trace, if enabled, the agent immediately reasons that it needs the calculator tool, provides the correct input, gets the numerical result, and then formats the final accurate answer. Now, a question that requires external up-to-date information. What is LangChain framework? The agent recognizes it cannot solve this internally, calls the web_search tool, and retrieves a concise, accurate definition from the internet. The speed of Groq is key here, enabling this tool calling and response in mere seconds. For our final example, let's challenge the agent with a multi-step calculation. The query is, calculate 2 times 512 and then calculate 1024 plus 500. Watch how the ReAct loop comes into play. First, it reasons and calls the calculator to get the result of 2 times 512. Then, it observes the result, reasons again, and uses the new value to perform the second calculation, finally outputting the correct answer of 1524. In summary, you've seen how to combine the lightning-fast Groq LLM with LangChain's agents to create a powerful tool-using ReAct agent. This pattern of reason, act, and observe is the foundation for building highly capable LLM applications. Thank you for following along.